So when you've been taught trigonometry, you might look at more real life problems which tend to be angles of elevation or depression, which involve using something called an inclinometer, which measures the angle you're looking at something and the distance you are from the object to work out the height. So you can see here that someone's done that with a tree. They've gone 20 metres away from, 31 metres away from the tree, and that's, at that distance, it takes 20 degrees of elevation, so you've got to turn your face up 20 degrees in order to be able to see the top of the tree. I've got a couple of these in my classroom, and my students always call them angle guns, because you literally look down the scope, pull the trigger, wait for the protractor to stop swinging, and look at what it lands on. So they call it an angle gun, but the correct word is an inclinometer. So anyway, let's have a look at our tree first. No working out room, of course, so I'm going to have to square paper. So first of all, I'm going to draw myself the triangle. I'm not going to bother about the tree or the grass or the blue sky or any of that jazz. I just care it's a right angle triangle with a 20-degree angle here, and I know that the base of it is 31 metres. There's an angle involved, so I know I'm going to be using trigonometry. So let's have a look at what I'm interested in. I obviously know this side here, and this is the adjacent side because it is next to the marked angle, and I want to know the height. So this is what I want to know, which is opposite to the marked angle. So if I'm using the opposite and the adjacent, well, sine uses the opposite and the hypotenuse, cosine uses the adjacent and the hypotenuse, but the tangent ratio is what I'm going to be using. You might have used SOHCAHTOA. So I've got A and I've got O. TOA is the one with two circled. So I always get my students to write it out in full. So the tangent ratio for a 20-degree triangle is between the opposite and the adjacent side. That's important, so you get them the right way around. That's x over 31. I just want to know what x is. So to do that, I'm just going to rearrange this equation. I'm going to multiply both sides of my equation by 31. And that's going to tell me x. That's literally all the working out I need to do in my head. I now get my calculator. Check that your calculator is in degree mode. There should be a little D at the top of your calculator. If it's not, then fiddle around if it is. 31 multiplied by, oops, not very good light there, is it? Oh, syntax error. Yeah, that shows me I've done it wrong. 31 multiplied, oh that's better. 31 times tan 20. Some calculators you need to put brackets, sometimes you don't. And it gives me 11.283 blah 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 blah. What was it one? Nearest metre. So nearest metre, that's going to be 11. That's what I put in my box, 11. So what I did there is I completely blocked out the fact that it was a tree, that it was grass, that it was high. I just drew myself a triangle and worked out what I needed. The radius mass is blah blah blah. Work out the length of the cable. So draw yourself your triangle. Oh, I just realised you can't see what I'm drawing. Draw yourself your triangle. Hopefully your triangle is slightly better than mine. I know it's right angle triangle, it's got 63 degrees. Tells me this is 52 metres, and I'm interested in the length of the cable. That's my x. So label your sides. 52 is opposite the marked angle, and x is the hypotenuse side. So SOHCAHTOA, or learning the ratios, whatever you do, we are using the sine ratio. So the sine ratio is opposite over hypotenuse. Hypotenuse, not hypotenuse. So for this triangle, which is a 63-degree triangle, we have 52 is the opposite over x. This is why it's important to write the fraction out. So many people would just put straight away x on the top. X on the top of your fraction is the numerator. That's not correct. Now, I'm going to show you the long way to do this, and then I'm going to show you the quick way. So, what we do now is we multiply the left-hand side, well, the whole thing by x, which gives me x times sine 63 equals 52. Then, then you take the sine 63 and you divide by it, which gives me x equals 52 divided by sine 63. Okay, that is the correct method, and that is why I am now going to show you the trick. So let's take back to this one here. X was on the top of my fraction. Because it was on the top, I times 31 times the trigonometry bit. Okay, the number in the fraction times by the trigonometry bit. Here, x is the denominator. Because it's the denominator, I divide by the trigonometry bit. Really useful trick. Top times denominator divide. So, as long as you understand why, and that's why, because of the rearranging. So let's have a look. We've got 52 divided by sine 63. 58 point blah blah blah, 58. Yes, that's 58. Okay. Now, this question here would throw some people, because well, no, but because of parallel lines, if this angle is 39, this angle is 39. I'm not even going to bother drawing out this triangle because it's pretty much there. What am I interested in? I am interested in the length far is the cliff from the boat. So when we talk how far is the cliff from the boat, we're talking about in a straight line on the water. So we're interested in this. This is my x meters. So I label my sides. Here's my angle. So 94 is opposite my angle. And x, my distance, is the adjacent next to my angle. So O and A, I've got nothing to do this one, is tangent, because tan is the opposite over the adjacent side. So tan of what angle? Tan of a 39-degree angle equals the opposite, 24, over the adjacent, x. But remember what I said? Top times denominator divide. What's this? Denominator. So we're going to divide. So into my calculator, I will put 94, number bit first, divided by the trigonometry bit, tan 39 degrees. Giving me 116 point blah. Okay, that's how we do those ones. Harder questions. The reason these are harder is because we've got two triangles involved each time. So we might need to do two little diagrams. It's alright, we can do that. But it does mean I'm definitely going to need my square paper. 1 decimal place or better. The last ones were to the nearest whole number. A man 2 metres high observed the angle of elevation at the top of the building to be 61 degrees and the angle of depression at the bottom of the building to be 28 degrees. How tall is the building? Why is it important that he is 2 metres tall? Well, because when you are looking at things, you are not looking at things from the distance to the ground. You are looking at things from your height. So even though the man is 2 metres high, technically his eyes are not on the top of his head. In fact, if you've ever studied face portraits, you know they're about halfway down your head. But that's just, ignore that for now, okay? Because otherwise we're just splitting hairs. So let's have a look at my first triangle, my top triangle. 61 degrees. I know it's a right angle because it's a vertical wall. And he, and we want to know the height of the building. So this is what we want to know, the height. Oh, but we don't know this, do we? It hasn't told us how far away he is. So maybe we need the bottom triangle first. Let's draw the bottom triangle. I've very purposefully split them. I've not very purposefully drawn them terribly out of kilter. 28 degrees here. That's 2 metres, and that must be 2 metres, mustn't it? Okay, oh, hang on. This length here must be the same as this length here. I'm going to call that D for distance, okay? So if I find out what D is, I can find out where H is, and then the wall is H add 2. So first of all with this one, I've got 2, which is my opposite, D, which is my adjacent. I'm not going to go through all the steps. I must be honest because it's 9:20 at night. So it's O and A, it's tan 28 equals opposite over adjacent. It's the denominator, so I'm going to divide. And that gives me 3.76. So I know that this is 3.76. I'm going to relabel it here, 3.76. Now I can find H. Use red to label this one. So H here is the opposite, and this is the adjacent. I'm still using tan, still using the tangent ratio. Tan 61 this time equals H over 3.76. This time the unknown is on the top. Because it's on the top, I'm going to times 3.76 multiplied by tan 61. Now you'll notice I still had this long number in my calculator, so I'm going to keep that there. Rather than press clear and type in 3.76, this is more accurate, so I'm going to just click times. Now if I had forgotten and had done all clear, I could still press answer and it would bring that up for me. So answer times tan 61, giving me 6.785. Let's just go for 6.78. So that tells me that this is 6.78. This is 2. So how tall is the building? 8.78. We want it to one decimal place. It's going to be 8.8. Right. I love this kind of question. That's just because I'm a maths teacher, so I'm weird. From a point to the water's edge, a bridge, arch, blah 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 blah, and left, can the yacht pass under the bridge? So we need to work out how tall the bridge is. I'm going to call that B, and how tall the yacht is. I'm going to call that Y. So we've got 2 triangles. This time, however, they have no sides in common. We just need to find out B and we need to find out Y. So we first of all do our bridge, which is 3 degrees. Right angle there, we're 59 metres away from the bridge, and we're trying to find out B, the bridge. That's the opposite, that's the adjacent. Usually when we use angles of elevation and depression, we are using tan. Usually, not always. Opposite B over 59. So we're going to get B is on the top, so we're going to do 59 times, top times, tan 3. Let's make that 3.1. 3.1 for my bridge. And then my yacht. Let's leave that out. 13 degrees this time, so we're looking a bit further up this time, 14 metres for that, and we want to find Y, the height of the yacht. Again, we look in the opposite and the adjacent, which means we're using the tangent ratio. Tan 13 equals opposite over adjacent. Y is on the top, so we're going to times 14 times tan 13. Put that into a calculator. And it gives me 3.23. Only wants one decimal place. 3.2. Will that yacht pass under that bridge? No, it won't. Your boat might pass under your bridge, so please don't just assume that it's definitely no. Work it out. Don't just copy. That's why the only reason I do these videos is because MyMaths randomly generates the numbers. Otherwise, I think maths teachers all over the country would hunt me down. So please don't just blindly copy, make sure you're working them out, but hopefully this will show you how.